Hello, this video is going to cover section 4.9 in Algebra 2, or it's over quadratic systems. And so we have two equations, or two systems of equations, but they're not linear. So the section we've done before, where they were all lines and you found where the lines cross, this time we might throw in a quadratic. So let's look at these three pictures that I drew here for you. So if I have a line and a quadratic, a parabola shape, then they could cross in two places and have two solutions, and you have to give the points the x and the y at each of those spots. Or like the line could barely nick the edge and only touch in one place, or they could never touch at all and have no solution. So when you're doing these type of problems, it is nice to have a graphing calculator, either an online or one in person, and graph them and see if what situation you're looking at, so you know where you're going with that. So I'm going to show you by hand how to do them, and I'm also going to show you on a TI-84. Okay, so let's go with my first example. It looks like y equals negative x squared plus 5x plus 6, and y equals x plus 6. Okay, so here are, there's my two equations. So these are in the form y equals, so that makes them really easy to put in a calculator. So I'm going to put them in a TI here. Where else could you could go to an online calculator. I know I've sent a link for Algebra 2 to that Holt one that we used last year, and that one works fine for just graphing. Or if you have a calculator, any similar calculator to this, that's great. I hit y equals, and then I'm going to put in these two formulas. It's still like kind of shiny. We'll have to deal with the glare for a minute. Maybe if I move it. Nope, still a glare. Okay, so I have negative. Use the negative way down here at the bottom. Not the minus sign, but the negative when you have a number in, or a negative in front. So negative x squared plus 5x plus 6. Enter, and then I want x plus 6. So remember, this is your x function, x right here, for when you're putting them in y equals. Now you can't put an x somewhere else and it solve for x for you, but that's the x you use for graphing. Man, that still doesn't. There we go. So I'm going to hit graph. And there's my first one, there's my second one. So it looks like we have two solutions. Now we could get those two solutions on the calculator. It's kind of a long process, but above trace, there's a calculate. If I go to secondhand calculate and I go to intersection, I hit intersection, and this is where it's tricky. You have to move this little guy on the left side of the point you're trying to find and hit enter. Then you have to move him on the right side of the point you're trying to enter, and then you hit enter, and then you have to hit enter again, and it gives you the intersection. Although it gave a decimal, and this one doesn't have a decimal answer, so it's a little bit off, but it's close. If we see the E in there, that means it's scientific notation, and it's moved over negative 15 times. So if you move that decimal over negative 15 times, you're going to have 0.00000000015.9. So you can see that's about 0.6 is where that one says it's at. And I have... Yeah, okay. Man, that's like off. I don't know why. So intersection, if I want to get the second point, I go on one side, and then I have to go on the other side and hit enter, and I get the right intersection on that one, 410. All right, let's do it by hand. So we can get that with the intersection, and the intersection on the other one that's online is actually a little bit easier, I think, than the intersection on that one. But all right, so let's look at how we solve this. Well, these are both set equal to y, so we're going to start with substitution. And we want to see where they're equal, right? So we're going to put this one in for this one, or for the y. So we're going to set them equal to each other so that I have x plus 6 equals negative x squared plus 5x plus 6. And then from here, it has an x squared in it, so I have to set it equal to 0 and then use factoring to solve. So I'm going to minus the 6 over and minus the x over. Notice I lined them up with the x's and the numbers so that I have 0 equals, so I still have the negative x squared. 5 minus 1 is 4. So I have 4 x's, and 6 minus 6 is 0. So here's my 0 equals my quadratic that I have to solve for. So I'm going to factor. And a lot of these factor out an x because there's not a number, so I don't have to do the other type of factoring. So this one I can factor out an x. I get negative x plus 4. So basically you took one x from here, one x from there, and it goes in front. And then those are your two terms. So what we do from there is we take each term and we set it equal to 0 and we solve, and those are the two answers for x. So we already have one, x equals 0. The other one is minus the 4 over, and I'd have negative x equals negative 4. Well, I can't have a negative x, so I divide by negative 1 to get x is equal to regular 4. So those are my two x's. So remember we had that really weird decimal for x, it was like 0.0000. That really is a 0. And the other one's a 4. And now we have to find the y's that go with these two x's because we want x and y at each spot. So we're going to find y. And that's our second step. So our first step is to solve for the two x's and then find y. So I go back up, and you could use either original equation. Well, this one's way easier than that one. So if I put in 0, for the first one, y equals 0 plus 6, and we can see that y is 6. So when x is 0, y is 6. And if you plug that into the other equation, you'll get that same point as well. Okay, so here's our first answer. Second answer, I put in the 4. So y equals 4 plus 6. And so we would get y equals 10. And so I just picked the easier equation. If you put 0 in here, you get 6 as well. Oops, you can't quite see what I said. 0 in this one, you get 6 as well. If you put 4 in this one, you get 10 as well. So you get the same answer no matter what equation you put back in for this part. But that's, go with the easiest one. Oops, I circled the wrong thing. I got to do 4, 10. That's the answer. Okay, so here's our two solutions. Let's do another one. Or a couple. We're going to do two more. Okay, so what if I have y equals negative x squared minus x plus 12, and I have y equals x squared plus 7x plus 12. Okay, so these are both, I keep going higher. Maybe I'll move my thing. I keep going higher than my, because of the way my desk is designed here. Okay, so I have two that are an x squared. That means they're both a parabola. So let's look again at what these look like in general. So I'm going to hit y equals and clear out, push clear, and then enter, and you can see those equations are gone. So I'm going to put in negative x squared minus x plus 12, and I'm going to put in x squared plus 7x plus 12, and I'm going to hit graph. And I can see they're both parabolas, and but they cross at two different places here, and you can see it looks like maybe 0, 10, and maybe negative or 5, 0. So that's what we're kind of looking at there. Okay, so let's do the same thing we did before. We're going to start with substituting. And so we'll put this one in for y, so you basically set them equal to each other. So I'm going to have x squared plus 7x plus 12 equals negative x squared minus x plus 12. All right, so I have to move all of these terms over and then factor. So I'm going to go this way. It doesn't really matter, but I didn't go in this way just because then it's positive. So I'm going to plus an x squared over, so plus x squared, and I'm going to add 1x, and I'm going to minus the 12 over. So this side becomes 0 because everything is moving this way. 1 plus 1 is 2x squared. 7 plus 1 is 8x. And the 12's actually went to 0, so there's really not anything there. You don't have to write anything. So it's a little far apart, but that's okay. So then on this side, again, I only have 2 terms, and they have an x in common, and they have a 2, but it doesn't really matter if you take that out or not. But so we're going to take out the x, and we're going to be left 2x plus 8 equals 0. And those are your 2 terms that you let equal 0. So the first one's x equals 0, and there's one of our answers. The other one is 2x plus 8 equals 0. So I set each factor equal to 0. Minus 8, and I would get 2x equals negative 8. Divide by 2, and x is equal to negative 4. So those are my 2 x values, 0 and negative 4. Okay, now I have to find those matching y's. Not as easy on this one because both of our originals were quadratics, but that's okay. So we're going to find y. And let's do x equals 0 first. So we'd have, I'm going to use the second equation because it doesn't have that negative that always throws people off. So I'd have 0 squared plus 7 times 0 plus 12. Well, 0 squared 0, 7 times 0, 0. So 0 plus 12 is 12. So the first point is 0, 12. And we saw that, I said it was around 10, so 0, 10 was up high. So here's the first answer. For x equals negative 4, you would have y equals, we'd go negative 4 squared plus 7 times negative 4 plus 12. Well, negative 4 squared is going to give us positive 16. 7 times 4 is 28, but it's a negative 28 because positive times negative is a negative, plus 12. So 16 minus 28 plus 12 actually ends up giving you 0. Okay, because 16 and 12 is 28, and then 28 minus 28 is 0. Okay, so we actually get 0. So when x is negative 4, 0. And we saw that, I said around negative 5, yeah, it'd be negative 4. Oops. All right, I keep looking at my paper and not at my screen. Not so good idea. I think if I, well, that's okay. If I put this up a little higher, but then it won't, I don't know if I can do that or not. Then it shows more of my paper. So here's our 2 solutions for that one. So they could both be a quadratic. A lot of the ones you're doing are lines, but let's do one more that's different. This one's going to have the greater than and less than. And all you can do is graph these ones. So let me show you what I mean. This is my third example. And if I have y is less than negative x, 8. I don't know why I just wrote an 8. Negative x squared minus 9x minus 2. And I have y is greater than x squared minus 2. So these are both parabolas, but instead of an equal, we have the greater than or less than. So this puts us in that shading instead of setting them equal to each other and finding where they cross. We are going to graph them both and then shade them. Couple ways we can graph them. You graph them just like it's an equal sign, and then you shade according to either less than or greater than. So let's make a little table of values. Well, we should do the vertex, really. That's the best thing to do. Or use a calculator, but that's okay. I'm going to start with the first one, and I'm going to graph y equals negative x squared minus 9x minus 2. And to find the vertex, it was negative b over 2a to find the x on the vertex. So I'm going to go ahead and do that so that I can find the actual vertex and be able to graph this a little easier than guessing. So negative b, so b is negative 9, so it becomes positive 9 because it'll switch signs. And then a is negative 1, so I have 9 over negative 1, or negative 2, excuse me, 2 times 1 is negative 2. So that's kind of an ugly, because it's a fraction, x value on our vertex, but you could think of it as a decimal. That might be a little easier, and that's just 4.5 negative. So that's our x value on our vertex. Now let's go ahead, now that we know our x value, let's find some points on this graph, xy. And I want x to be negative 4.5 so that I can find that vertex. And we'll just plug that into our equation here. So I would go negative for right here. And then you have negative 4.5 that you put in for x squared minus 9 times negative 4.5 minus 2. So I'm going to sneak out my calculator. So what happens when I have a negative squared? Well, that's going to become a positive. Make sure you use the parentheses. And that's going to be 20.25 or 20 and a quarter. And that's going to be negative. So negative 20.25 minus, well, this will become a plus because negative 9 times negative 4.5, 9 times 4.5 is 40.5 minus 2. So I'm going to take 20.25, excuse me, negative 20.25, and I'm going to add it to 40.5, and I'm going to minus 2. And I'm going to get 18.25. So we know when we go to graph this, hold on, I lost my ruler. When we go to graph this, that's our vertex. So negative 4.5, 1, 2, 3, 4, 5. So here's 5. So negative 4.5 and then 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10, 11, 12, 13, 14, 15, 16, 17, 18. Here's 18, 19. So we know it's about right here for the vertex. Way up there. Okay. So that's our vertex. Now let's find other points. Now that we know the vertex is there, let's look for a point on this side and this side. So here's 5. Let's go out, I don't know, maybe 8 or 9 or 10 or something like that. Let's just try 8. So I want to be on the left side of that vertex and the right side so I can see the shape. So let's just do 8. So we'd have negative 8 squared minus 9 times 8 minus 2. 8 squared is 64. 64, well, it'd be negative 64 minus 9 times 8 minus 2 is going to give me a, no, I did something wrong. 8 squared, let's just negative 64. 9 times 8, should the 8 have been negative? Yes, that's why I was like, wait, it's a huge number. I want to put a negative 8. That was what, this is negative 8. Oops. Let's put in the negative 8 instead. I was like, the number's 138. So over here at 8, there it's way up at 138. And I didn't really want to graph that. I went negative 8. Totally changes the problem. So this is going to be a negative 8 in here. Oops. And then there's the negative outside. So 8 squared, it's still the same negative 64 here because negative 8 squared is 64 and then it becomes negative. But this double negative becomes a positive 72 minus the 2, which really does change the whole problem. To 6. There we go. Negative 8, 1, 2, 3, 4, 5, 6. Negative 8, 6. It's about there. So if I put in negative 8, we could put in 0. That's way easy. Let's put in 0, and that's on the right side. So you'd have negative 0 squared minus 9 times 0 minus 2. That all disappears, and you end up with negative 2. So 0, negative 2. So we can see the graph kind of goes like that. Okay, now let's go back to this less than symbol that we had originally. That's what the graph looks like. So again, I always start with the vertex, point on each side. Not that easy to graph. So you should do a couple by hand so that you know how. From your book or Problems from Math Excel, I don't really care where you do it from, but you should do some by hand. And then you can do some by graphing as on the calculator as well. So I'm going to color this one gray, but this is less than. So anything less than would be around below on the y's from here. So it's going to fill out the middle and then keep going. So that's kind of what it looks like. Now let's graph the other one. So the other one is a little bit easier formula. We have x's and y's. Oops. Hopefully I didn't ruin my video. Nope, we're good. Okay. So the next one is a little easier because it is y is equal to x squared minus 2 for our graph. And we want the vertex of this one. Well, the vertex of this one, it's in vertex form. It's easy to see. 0, negative 2. Because you don't have the x term. It's like a 0 in here. So 0, negative 2 is already our vertex, and we'll graph that just a second here. And you could do the negative b over 2a and figure that out, but there's no b, so it's 0. And divided by anything is 0. So let's see. So another number, let's try 1 on the other side of 0. So we'd have 1 squared minus 2. 1 squared is 1, minus 2 is negative 1. And let's try on the negative side, maybe negative 1. Okay, so then we'd have negative 1 squared minus 2. Negative 1 squared is 1, minus 2 is negative 1. So let's graph those 3 points. And let's do this one in red. So we'd have 0, negative 2. Ooh, look, there's one of the places they cross. 1, negative 1. And negative 1, negative 1. Okay. And there's the graph of that second one. And this one was greater. Okay, so this was greater. So from y, where your greater is in here. And then what our solution is where they both were shaded. So can you see that it's going to be this section right here? Okay, so there's your two graphs, and there's the section that's the solution. So these ones are a lot harder because you have to remember how to graph, you have to remember how to find the vertex. All right, so if I did that on a calculator, I could just graph and see the graphs easy, but I wouldn't be able to do the shading unless you're in Math Excel. Okay, so then the shading could be in there. All right, those are the 3 examples I wanted to give you.